Good morning everyone. Welcome you again to the online classes. This class is for the students of class 11. And in last class we solved exercise number miscellaneous exercise of a complex number, and we solved up to question number 15. Not for 15, question number 13. We'll solve today from question number 14. Okay, so let's start from question number 14. So find the real number x and y if x minus iy into 3x plus 5y is the conjugate of minus 6 minus 24i. We have to calculate the value of x and y such that this number is conjugate of that number. Clear? So let us consider this number as z. So z equal to this. That implies z equal to, multiply this. So x into 3x, this is not 3, this is x plus iy plus 3 into into 3 plus 5. So multiply it. So 3x plus 5x into I minus, if I multiply by iy, it will be minus 3y into I minus 5y into I square. That means 3x plus 5x into I minus 3y into I, and look, we know that I square equal to minus 1. So in place of this I square we can put minus 1. So that minus and this minus will be a plus. So 5 into y. That implies z equal to 3x plus 5y plus, if I take I common here, so 5x minus 3y. So this is the given complex number. Now calculate its conjugate z bar. So z bar will be 3x plus 5y. This plus will be converted into minus I into 5x minus 3y. So this is the complex conjugate of the given number, and it is given that the complex conjugate of given number is equal to this. So we can compare this number 3x plus 5y minus I into 5x minus 3y will be equal to minus 6 minus 24i. Now if I compare the real part with real part and the imaginary part with the imaginary part, then we have 3x plus 5y is equal to minus 6. This is the first equation, and the second equation will be 5x minus 3y is equal to 24. This is the second equation. Now from equation number 1 and equation number 2 we have to calculate the value of x and value of y. So you know this is a linear equation in two variables, and we know very well how to solve this type of equation. So we apply elimination method to solve this problem. So we multiply the first equation by 3 and the second equation by 5. We have 3 3s are 9x plus 5 3s are 15y is equal to minus 80. And if I multiply the third equation with 5, then we have 5 5s are 25x minus 15y is equal to, if I multiply 4 5s are 20, 2 5 2s are 10 and 2 120. Now add these two equations. So if I add it, so minus 15y and plus 15y will cancel each other. Then it's 9 plus 25, that is 34x is equal to, that is 102. That means x equal to 102 by 34. Choose up. So the value of x equal to 3. Now we have to calculate the value of y. Now if I put x equal to 3 in either equation number 3 or in equation number 1 or equation number 2, we have the value of y. So from equation number 1, we have 3 into x means 3 plus 5y is equal to minus 6. That means 9 plus 5y is equal to minus 6. That means 5y equal to minus 6 minus 9. That means 5y equal to minus 15. That implies y equal to minus 3. That means the value of x equal to 3 and value of y equal to minus 3, and hence solve. Okay? Now we'll solve question number 16. If x plus iy whole cube is equal to u plus v, then we have to u plus iv, then we have to show that u by x plus v by y is equal to 4 into x square plus y square. Okay, so now look, we know a formula that a plus b whole cube, which is equal to a cube plus 3a square b plus 3ab square plus b. So we apply this formula here. So if I apply this formula, it will be x cube plus 3 into x square into iy plus 3 into x into iy whole square plus iy whole cube. A cube plus 3a square b plus 3ab square plus b cube, which is equal to u plus iv. That means x cube plus 3 x square y into I plus now look, if I calculate this iy whole square, that will be I square into y square, and we know that I square equal to minus 1. So this equation, this term will be 3x into y square plus that will be, this term will be I cube into y cube, and we know that I equal to root over minus 1, I square equal to minus 1, and I cube equal to minus 1 into I, that is equal to minus I. So this term will be minus I into y cube, which is equal to u plus iv. Okay, now separate real and imaginary part. So these two terms are real term containing no x. So x cube minus 3x y square plus, now grouping the imaginary part, this part and this part. So if I take I common, it will be 3x square y minus y cube, which is equal to u plus iv. Now if I compare the real part and the imaginary part, then we can write that u equal to, u means the real part of this complex number, that is x cube minus 3x y square, and v will be imaginary part of the complex number, that is 3x square y minus y cube. From here we can write that u equal to, if I take x common, it will be x square minus 3y square. That means u by x will be x square minus 3y square. And here if we take y common, so y into 3x square minus y square. That means v by y is equal to 3x square minus y square. So u by x is known, and v by y is also known. Now put the value of u by x and v by y in here. So from the left hand side we have u by x plus v by y, that equal to, what is the value of u by x? That is x square minus 3y square. Put it here. X square minus 3y square plus, what is the value of v by y? Which is equal to 3x square minus y square. 3x square minus y square. So this x square and this 3x square will be a 4x square minus this 3y square, and this y square will be 4y square. Now if we take 4 common, it will be x square minus y square. That means u by x plus v by y equal to 4 into x square minus y square. Actually we have to put this is x square minus y square, not plus y square. Okay, so hence proved. Okay, now solve question number 17. Question number 17 is, if alpha and beta are different complex number with mod v equal to 1, then find the value of modulus of beta minus alpha by 1 minus alpha bar beta. Alpha bar means conjugate of alpha. Okay, so alpha and beta are two different complex number. So let us consider alpha equal to a plus ib and beta equal to a minus ib, and it is given that modulus of beta equal to 1. Modulus of beta is equal to 1. That means from here if I calculate the beta equal to c plus id. So if I calculate modulus of beta, so mod of beta will be c square plus d square root over, that is equal to 1. Means c square plus d square is equal to 1. Okay, so make it a number, equation number. Wait, this is our first equation. Okay, now calculate this term, mod of beta minus alpha by 1 minus alpha bar beta, which is equal to modulus of, okay, put the value of alpha and beta. So beta equal to c plus id minus value of alpha equal to a plus ib divided by 1 minus value of alpha bar is equal to value of alpha bar equal to, look, alpha equal to this, so alpha bar will be a minus iota b. So a minus iota b into beta means c plus iota b. That is equal to modulus of, this is c plus id minus a minus ib by 1 minus, multiply these two complex number. So that will be AC plus IAD minus IBC minus I square BD modulus of that. That is equal to, okay, that is C plus C minus A plus iota into D minus B divided by 1 minus. Now remove the bracket, so it will be 1 minus AC minus AD into I plus BC into I plus that will be minus I square. So that will be minus BD. Okay, now look, we know the formula that mod of Z1 by Z2 is equal to mod of Z1 by mod of Z2. If we apply this formula here, we can write that is mod of C minus A plus I into B minus B by modulus of 1 minus AC minus BD plus I into BC minus AB mod. Okay, now calculate this modulus. That will be under root over of C minus A whole square, C minus A whole square plus D minus B whole square divide by under root over that is 1 minus AC minus BD whole square plus BC minus AD whole square. Now calculate this, expand this expression and this expression by the formula. So we have this is under root over okay, if I expand this expression, it will be C square plus A square minus 2 AC, and if I expand this expression, it will be D square plus B square minus 2 BD divide by expand this expression, that means A minus B minus C whole square, that is A square plus B square plus C square minus 2AB minus 2AC plus 2BC. Use this formula here. So we have 1 plus A square C square plus B square D square minus 2AC minus 2BD plus 2ABCD, and if I expand this expression, it will be B square C square plus A square D square minus 2ABCD. Now this plus ABCD and this minus ABCD will cancel each other. That means finally we have root over of this is A square plus B square plus C square plus D square minus 2AC minus 2BD divide by root over of 1 plus. Now if I take A square common from this term and this term, then we have A square into C square plus D square, and if we take B square common from here and here, we have B square into C square plus D square, and remaining two terms are 2AC minus 2BD. That is equal to under root over. Now look, we from condition number 3, there is a condition that C square plus D square is equal to 1. From where we are getting that mod B equal to 1, mod B equal to 1, mod beta equal to 1. From here we got a relationship that C square plus D square equal to 1. So we put C square plus D square equal to 1 in here, here and here. We have A square plus B square plus 1 minus 2AC minus 2bd divided by root over of 1 plus a square, this is equal to 1, plus b square because this term equal to 1, minus 2ac minus 2bd. Now if you slightly rearrange this, so you can see that this expression and this expression are same, so cut them, so answer equal to 1, and hence the problem solved. Okay, now we'll do the last questions of the exercise, means question number 20, and this is the last question of this exercise also. Okay, so question number 20 is, question number 20, if 1 plus I by 1 minus I whole to the power n is equal to 1, then what is the least integral value of n? Okay, so we have to find the least integral value of n. That means 1 plus I by 1 minus I. So we are multiplying the numerator and denominator by 1 plus I and whole to the power n is equal to 1. That means that term will be 1 plus I whole to the power whole square, and it will be 1 square minus I square whole to the power n is equal to 1. Now if I expand 1 plus I whole square by the formula, so 1 square plus 2 into 1 into I plus I square by 1 square plus 1, because I square equal to minus 1 whole to the power n is equal to 1. That means 1 plus 2i minus 1 by 2 whole to the power n is equal to 1. So this plus minus 1 and this plus 1 will cancel each other. That means we have 2i by 2 whole to the power n is equal to 1. 2i by 2 whole to the power n is equal to 1. 2 and 2, so I to the power n equal to 1. Okay. Now I to the power n is equal to 1, and we know that I to the power least value of n will be equal to 1, because I equal to root over minus 1, I square equal to minus 1, I cube equal to minus I, and I to the power 4 is equal to plus 1. So least value of n will be equal to 4. Clear? So finally we have completed our exercise. Not only the exercise, the whole chapter also. In my next class we will start our next chapter, that is the linear inequalities. Okay, thank you.